Hi folks, Chris McClure here. Last time we talked about the binomial probability distribution, our first distribution that is discrete. We're going to talk a little bit more about the binomial distribution today, and then next time we'll talk about the Poisson probability distribution, which is another discrete distribution. So about the binomial distribution, we're going to talk about parameters today, and in particular how to calculate the mean and standard deviation of the binomial distribution. Okay? And talk about interpreting and understanding the mean and the standard deviation. Now, straight up, here's the calculation. Now, remember that little p is the probability, is the probability of a single success. So, for example, p would be equal to 1/6 if we're talking about rolling a die and observing a 1. And n is the number of trials. In other words, it's the sample size. So the mean is going to be calculated by taking the sample size times little p. Variance, sigma squared, is n times p times q. Remember, q is 1 minus p. So for the roll of a single fair die, little p was 1/6. Q is 5/6, probability of a failure. Standard deviation is the square root of variance, square root of n times p times q. Okay? And, once you calculate and know what the mean and standard deviation is, mu and sigma, then we can go back to something that we encountered in previous chapter by talking about what it means to have a usual or versus a non-usual or unusual sort of event or observation or whatever. It's by taking mu, as in the mean, plus or minus 2 standard deviations. And any value within 2 standard deviations of the mean would be a usual, or at least not unusual, observation. But if the observation is greater than 2 standard deviations above the mean, or less than 2 standard deviations below the mean, then that would be an unusual observation. So, for example, this real easy example here, suppose that we know from past experience that 95% of adults recognize McDonald's as a restaurant. So suppose that we were to randomly select 12 adults from the population and ask each one of them, do you know what McDonald's is? Or is a McDonald's a restaurant or whatever? They either recognize the name or they don't. So this is going to be a binomial experiment, because for each person they either recognize or they don't recognize. We will count a recognition as a success and a non-recognition as a failure for each individual. Now, for this experiment, the expected or average number of adults would be 12 times 0.95, where 12 is the sample size and 0.95 is the individual p-value. 12 times 0.95 is 11.4. And also for this binomial distribution here, because that's what we have here, sigma, standard deviation, is square root of npq. N is 12, p is 0.95. 1 minus p, which is q, is going to be 0.05. And square root of that product, it works out to be approximately 0.754983. In other words, about 0.8. So there's an example of us calculating the mean and the standard deviation for this distribution. Also, we can take a look at using the range rule that says that at least 95% of such experiments where we recognize or select 12 people randomly and ask them, each one of them, if they recognize McDonald's, 95% of such experiments would result in between 9.8 and 13 people recognizing McDonald's. Because, if you were to take mu plus 2 sigma, that's 11.4 plus 2 or 2 times 0.8. 2 times 0.8 is 1.6. 11.4 plus 1.6 is 13. Also, mu minus 2 sigma, that's 11.4 minus 2 times 0.8. That's 11.4 minus 1.6. That's 9.8. So if we were to have an experiment in which we randomly select 12 people and ask each one of them if they know what McDonald's is, it would be unusual to have less than 9.8 people, meaning 9 or fewer people, or greater than 13 people. Now, as in that number of people who recognize McDonald's. So greater than 13 or less than 9 would be an unusual observation. And in this case, for this particular problem, we shouldn't expect any more than 12, because guess what? We had already said that we are only choosing 12 people for this. So we would probably trim this down to between 9.8 and 12. So it would be a real surprise if you told me that 13 people recognize McDonald's. But if you were to say that 9 people out of the 12 recognize McDonald's, that would be unusual and surprising as well. And any number below 9.8 would be unusual, because it's outside of that region, plus or minus 2 standard deviations of the mean. Okay, so that's it today. That was a real quick discussion. Tomorrow we'll talk about Poisson distribution. Okay. By the way, I have sent out tests for those people who have told me their testing location or sent me their proctor form. Now, there's still a pretty good number of people in the class who have not told me where they're taking their tests. So if you are one of those people, you need to contact me if you have not told me where you're going to take your test at some DMAC campus or with the proctor. Okay, so make sure that you do that, because the time is ticking. I want to have everyone take their tests by next week on Wednesday, June 25th. Okay, folks, have a good day, and I'll talk with you next time.